Hello, I'm Lilli Thompson, and this is building game development tools with App Engine, GWT, and WebGL. So if you want to give feedback during the session, there's an official speaker meter page, and there are also some official hashtags if you want to chat about it. And I'll show this slide again at the end if you don't get the information right now. So first of all, the structure of this talk. So I'll start out sort of defining the problem space and talk about why we need game development tools and why this particular set of technologies is a good fit for this problem. Then I'll show you a demo of a couple of really good motivating use cases of tools on these technologies. And then the second half of the talk is really the meat of things. It's the story of how those demos were made. There were all sorts of things I sort of stumbled into while I was developing. And it's about sharing that development process. All right, so my background is in console game development. Before joining Google as a software engineer, I was the lead of tools and central technology at Secret Level Sega. And game tools are something I'm really interested in. It's something I've done for a lot of my career. And when I came to Google and started working with App Engine and GWT, I was super excited because these were technological solutions to very real game programming problems I'd had in the past. So the motivation behind this talk is really sharing that thought with you. This talk is for anyone who's interested in game development tools. And I expect a lot of people here to be interested in browser games. But actually, the same technologies and techniques would work equally well for mobile games or even some tools for console games. So what are we talking about? What exactly do I mean by game development tool? Well, first we should talk about the type of data we're going to support. And the kind of assets I'm talking about are geometric assets. So you have big mesh data. And the thing about geometry data is that it is just so much bigger than the stuff most people are used to dealing with on the web. You've got these big binary files and all this custom logical data like rigging data and trigger data that doesn't have a natural visualization for your tools to use. And on top of that, you've got a lot of multimedia stuff like sound effects and video and that kind of stuff. And on top of all that, all this complicated multimedia data is connected together in a big web. So for instance, your character assets are going to reference rigs. They might also reference meshes. Your meshes might reference materials. Your materials might reference textures and shaders, even particle effects and sounds and all that kind of stuff. So you've got complicated data and complicated connectivity between that data. So you're going to need tools to set all that up. And when I say game development tool, probably the first thing on a lot of people's minds is level editors. And level editors are important and interesting, but I just wanted to point out that that's just one of many types of tools you might need. You might need a way to set up your material bindings, or define metadata on your assets, or if you have any sort of skeletal animation system, you might need an HSM editor. Or if you have cutscenes in your game, you might need a cinematic editor, or logic editors. There are all kinds of opportunities for different kinds of tools on all scales. So what's interesting about tools programming with respect to engine programming? And I point this out because it's going to affect your choice of technology platforms for one or the other. And the thing about tools is that in all likelihood, they're part of the process of making your game, not part of the product itself. You're probably not shipping your tools. And what that means is that for your game engine, you might be willing to go through all sorts of contortions to wring every last bit of performance out of the platform that you possibly can. And you might be willing to sacrifice ease of development for performance. And that would likely be a pretty bad decision for designing your tools. Because if the #1 priority for your game engine is performance, then the #1 priority for your tools is probably something else. It's like rapid iteration time or quick debugging. So the two different uses really do have different technological priorities. And a different technology platform is often warranted. And you see this in the console games industry, where it's a really popular choice to develop your game engine in something really fast, like C or C++, and then do your game tools in a different language entirely that's optimized for these other concerns. For instance, it's really common for console game studios to write their tools in C#. So if you've got a browser game, you might be thinking to yourself, well, my engine's like pretty small in scope, and my data isn't too complicated, my team's pretty small. Maybe I can do all the data setup and authoring I need to do just by hand authoring a text file, something really, really simple. If that's the scale you're working on, do you still care about game development tools? And the answer is yes. Yes, you absolutely should care. It's true that web games and mobile games and all these new media forms of games, on the whole, are simpler today than console games. There's no doubt about that. But it is amazing how quickly the quality of the content and the complexity are going up, and the expectations of users are going up along with them. And we saw this in the console games industry about 20 years ago, when game engines were much smaller and the platforms had a lot less power. And you could pretty much just hack things together, and tools weren't that big of a deal. And then year after year, the consoles grew and grew and grew in power. And before anybody really knew how to solve these problems well or acknowledge that they were really important problems, there was this dramatic need for tools. And the console industry had to stop and do a lot of catching up and learning. So y'all should learn from that. And even if you're doing a game in the browser or a mobile game and it seems simple today, you will need tools. And good tools will increase the quality of your content and the quality of your game. I guarantee it. OK. So hopefully we're all on the same page and think that developing tools is a really important part of developing a game. But there are many different platforms on which you could write your tools. So why would you use these particular technologies? So there are a couple of key concerns for your tools platform. For one thing, you have to consider the development skills your team has and where you want them to grow, so what technologies you think might be important in the future. Sometimes tools are a good way to try things out. Tools are all about UI, so you're going to need some library with a lot of widgets and text boxes and list boxes. You'll need all that. You also have to consider setup overhead. So every time a new team member joins your team, you're going to have to get them set up with a development environment for your game. And if it's a big, complicated install process, that's a lot of work for you. And also consider that the trend in game art has been to working with off-site artists. And that just underscores the need for simplicity of setup of your tools. And then, as I mentioned, debugging is absolutely top priority. So how does App Engine fit into all this? Well, App Engine is Google's cloud services framework. It's a set of APIs and tools that help you build an application and a way to host them. And I think the number one reason you would want to use something like App Engine is for collaboration. Really, the first reasons that you might want to use App Engine are just reasons to put your tools in the cloud. And that's to have things in a collaborative environment. And we talked about the need of ease of setup. And so if you have things in the browser, there's no executable for each user to install. There are no command line arguments to know or anything like that. Setup's super easy. Everybody knows how to use a browser. And then the thing that makes App Engine particularly great for this use case is that, like I mentioned, the tools are probably not your product. You're busy making your game. So you probably don't have a lot of time devoted to buying hardware and managing an authentication system and load balancing and all the kind of framework and boilerplate you need to get set up for a web app. And one thing that App Engine does really, really well is provide a lot of supporting APIs and have a really good new user setup. So App Engine is great for this use. All right, so backend's in App Engine in the cloud, but there are many ways to write the front-end UI for your web app, so why would you use GWT? So GWT is Google's framework for making web apps. It is a way to compile Java code into JavaScript that is optimized for different browsers. And what's cool about that? Well, what GWT really gives you is a scalable development environment. And what I mean by that is that JavaScript is great for rapid prototyping. That's one of the things it's really good at. But if you have a big application, and tools are big applications that have a lot of moving parts, going to live a long time, a lot of people are going to work on it, you really benefit from something with a little more structure. And that's exactly what the Java of GWT gives you. You have all the idioms and patterns of Java there to use, and yet it compiles to JavaScript. And on top of that, GWT has a lot of really nice widgets. If the ones that are there don't suit your needs, you can write your own. That's really easy. And the whole thing's open source. All right, so backend's in App Engine, UI's in GWT, but now we need a way to render 3D data. So why would you use WebGL for that? Well, if you're a developer and you want to render 3D data, there are pretty much two games in town for working in the browser. There's Molehill, which is the 3D functionality in Flash, or there's WebGL. That's pretty much the choice you're making. So why would you want to use WebGL? Well, it's nice to have an API that doesn't require any plugins. So the browser just renders WebGL natively, and that's one less thing to set up, and we talked about how ease of setup was important. On top of that, you're probably going to be mixing a lot of Java and JavaScript for your application because there are a lot of of cool JavaScript APIs that are useful to game development. So having WebGL be in JavaScript is really nice. Everything's sort of together in JavaScript. You can use the browser JavaScript debugging tools that you're already using for everything else. Not to mention, there are some really cool third-party tools for WebGL debugging. For instance, WebGL Inspector is one of them. And on top of that, it's just a really fast, nice way to do your drawing. All right, so that's the background. Let me show you a demo of a tool built using these technologies. Whoa, why am I black screening? Aha. All right, so this is my demo. And what this is it's just an asset viewing tool. So the idea here is that you sync to version control, where you're probably checking in all your assets, and then you can see them in the browser. So you have a bunch of meshes, you can sort of page through your data. This tool supports shaders, textures, and meshes. So if I look at my thumbnails, I can see there's a bunch of mesh data up at the top. Then I have a bunch of textures. I have about 90 assets loaded into this database right now. And then shaders down at the bottom. And so the idea here is that you can examine your data to see that it is what you expect. And then over here on the right, I have a property grid sort of thing where I pulled out key information about this object, including its name and its ID. And of course, its poly count. So you can see this model here is only about 2,500 polygons. It's not particularly big. But if I contrast that with this character model, this is about 130,000 polygons. You can see he's very, very dense. You can sort of examine his topology in wireframe, which sort of helps you get a handle on what's going on here. This model is the biggest thing I actually have in this database right now. It's about 200,000 polygons. It's so dense that it's actually sort of hard to parse in wireframe. So it's cool that you can just sort of look at your stuff like that. So this was the very first tool, just an asset viewer tool, that I thought of when I started trying to think about doing game tools in the browser. And it was really exciting to me because this is a tool I'd actually wanted to write at a previous game studio. We had this idea that we wanted to write this tool, but we didn't have the technology. And the strong motivation behind this is that oftentimes big game studios own a lot of little game studios, or studios work together as partners. And it's really hard to see what each other are doing. So it's very common to have 3 different artists at 3 different developers all making photorealistic rocks or crates or grass textures or any of this kind of stuff that's really common. And just having a way to view it in the browser, which is what you can do with App Engine, is a really strong use case. So anyway, I was really excited about just the asset viewer, but I added a few more sort of little features that show off some things that WebGL makes really easy. So for instance, if I look at this Android model, this panel down here at the bottom shows his material bindings. And this is all live editable. And material binding tools are something that you find throughout the games industry. It's something I've written for a game studio before. So it's a really nice, realistic use case. And the idea is that his shader, you can just go, this browsing here shows me all the shaders I have in my database. I can set him up as a red shader. Or I can render his surface normals as RGB values. Or I've got a nice vertex displacement shader that makes him all noisy. Or my favorite is the toon shader, makes him all cartoony. And the cool thing is that all this shader code is live editable. So if you click over to the shaders tab, you see the program that's actually running on this asset right now. And on the left, you have the vertex shader. On the right, you have the fragment shader. And if I want to make him a little redder, I can do so. Or if I think his outline should be a little heavier, I can change that. So the thing about this is the sort of thing that WebGL makes super easy to do, because all your shader code and your programs, you can pass them around as strings in JavaScript, and all your data is right there in JavaScript. So writing an interactive shader editor, which was something that had been hard last time I tried to do it, is really easy with WebGL. So it's a lot of fun. And then of course, the texture channels that are inputs to these shaders are also live editable. So I can put him back to a flat shader and show, what if he were flat shaded made of brick or something like that. So it's all really nice, easy way to set up material bindings. And then I had one more use case I wanted to show you. We look at this robot, and the idea, this sort of totally different type of functionality, but the idea here is that maybe you've got 3D assets, but you want to make a 2D game. So what you really need is a way to take a bunch of snapshots of your mesh from different angles so you can compile them down into a GIF, or however you're going to store them. And that's what this tool does. And WebGL makes this very easy because you can just grab what's on the current canvas and upload that to App Engine. So for instance, here I select a number of images, a starting rotation, an ending rotation, and a resolution. 180 is actually big for this display. And then I can generate a film strip view of this asset. So you can see him sort of progressively rotated. And then I could take that and I could use it in my 2D game in a nice way. And this is the same technology, the same idea behind this that's being used to make these thumbnails over here. So if I think this Android would look better with a different screenshot, I can set his thumbnail. So anyway, so that's pretty much it for the demo. And the idea here is that WebGL makes material bindings and shaders totally easy and awesome and fun. And App Engine does this collaboration really well. And so that's the basic premise. All right, so back to the talk. Hello, keynote. All right, so before I go on to the second half of the talk, just a tiny word of caution, which is that some of the features that I used for that demo or that I'm about to talk about require leading-edge browser support. So I didn't want to give you the false impression that all these things were available in absolutely every browser, because they're definitely not. Now, wide availability is important and good, and it's important to note this. But I think, especially for this use case, it's actually less important, because you're developing tools for people at your game studio who you're not trying to support everybody in the web. So the people at your studio already need all kinds of custom setup. They need a 2D editor and a 3D editor and a copy of your IDE and a copy of your source code and so on and so forth. So saying, browse to the tools in a modern browser is just not that big of a deal, in my opinion, but I wanted to note that. All right, so let's talk about the technology that went into that demo. So the basic building blocks that I was trying to support are shaders, textures, and meshes. That's the data you saw in the tool. And the basic things I wanted to do with them are I wanted to be able to store them in the cloud, use the cloud to process them from an intermediate form into a built form of the assets, put them in a nice format where they're easily served to the client, and then render them on the client. So that's the box around the problem we're trying to solve. So the very, very first thing you're going to need to know for any of this technology is how you get from the Java code in GWT to JavaScript. Because I use a lot of JavaScript APIs, and WebGL itself is a JavaScript API. So you're going to need to know how to go back and forth. And the way you do that is with something called GWT JavaScript Native Interface, or JSNI. And what that is, it's your all-purpose window from GWT's Java into the JavaScript world. And what it looks like to write a JSNI method is that you write a Java method with this native keyword out front, like you can see on the slide, and then it looks to your Java IDE like the body of that method is written in JavaScript inside a comment. And you see, like in the example method, the argument passed in is used by the same name in the JavaScript, which is how you sort of get data from one side to the other. And you can be as object-oriented as you like with JSNI. You can either just inline all your JavaScript straight, or you can just call functions that are live in a JavaScript file somewhere else. Or if you're being fancy and you want to do a lot of stuff in Java, you can make Java classes that abstract out a bunch of JavaScript functionality and then treat them as objects in your Java. The amount of how you exactly set that up is up to you. But JSNI is the basic technology behind it all. All right, so if that was step 0, step 1 is like you want to build a tool, you've got some data, what do you do with it? So if you've got static data, you can deploy it just like you always deploy static data. You can just deploy it along with your app, the same way you put images on your web pages. So you can either have big directories of textures and meshes and shaders loose, but that's not a great idea because you're going to be doing a whole bunch of fetches, and that's not particularly efficient. Or a better idea is to ball everything up as resource bundles and then serve them to the client all at once. All right, so resource bundles sound like a good idea, but how do you actually handle that once you're working with it on the client? And the way you do that is with the HTML5 file system API. And what this is a way to get a sandboxed local file system that your browser can use. And it really is sandboxed, so you can't write all over the client file system. You can't write to my docs or anything like that. But within the sandbox, you can read and write directories, and you can read and write files. So you can do all sorts of cool file system-y stuff. And this is exactly what you would want if you had a big bundle of resources and you wanted to expand it locally and keep it organized on your machine. So this is what it looks like to use the file system API. Your way in is this function request file system. And you tell it whether you want persistent or temporary storage, and you say how much you want. And then you give it a callback that gets called when the file system is ready for you. And then once that callback is called, you do pretty much whatever you want. A very reasonable thing to do would be to check a hash of local resources against a hash of resources on the server and see whether there was syncing to do and sync accordingly. This is what it looks like to write a new file. So this is asking the root directory of the file system to get a file by a specific name. The function getFile is used for reading and writing. So here we say we're creating a new file. You specify a callback for what to do when the writing is done. Then you create one of these blob builder objects, which is how you get contents into your file. You put contents in it, you write it, and your callback gets called. Reading, very similar. Here we're asking the root directory of the file system to get a file by a specific name, create a file reader object, specify a callback for what to do when the file's done reading, then you read the file. So pretty standard file read-write API. There's nothing tricky about it at all. But it's super useful, and it's something you will definitely want if you're dealing with heavy resources. All right, so we've got everything in a resource bundle, and now we're serving it all together at once. But that initial download might be pretty slow because you're getting all your resources at once. So how do you speed things up? Well, the answer with static data for speed is pretty much caching. Caching, caching, caching. And there are many different types of caching. It doesn't stop at browser caching. There are a ton of different caching opportunities, so much that actually this would justify probably a whole talk. But I'm just going to go through a few things. I'm not really going to do it justice. So if you have static resources on App Engine, you can set up their cache expiration times in your App Engine web config file. So that's a good thing to know if you're serving big sort of static resources. Besides that, if you're responding from a servlet in such a way that you have control over the response headers, there are a couple of really important headers you want to set. So for instance, max age says how long something's going to stay in the cache. Or cache control public is a really good one. It says that intermediaries between the client and the server can store copies of your data. So if you're willing to allow that to happen, that can speed things up a whole lot for you. And then on top of that, just good caching technique, you want to use something called content fingerprinting, which is where you make the name of your file a hash of its contents, or something that changes when the contents change. And you do that because values are stored in the cache, but with the name of the file as the key. So if you correlate the two, then you can set a very aggressive cache timeout expiration on your data and not worry about your cache getting poisoned, because the name will change and then it'll get recached. There's also this thing called the HTML5 application cache, which is 5 megs of local cache data in the browser. The way you interact with app cache is through a manifest file that says what to cache and what not to cache. The way you associate yourself with a manifest file is by referencing it in your HTML. And then the one thing you need to know if you're doing this on App Engine is that, or actually in general, is that the file extension, or the cache manifest file, has to be served with the MIME type text cache manifest. So if you're doing this on App Engine, this is how you would set up that MIME mapping in your web.xml file. And it can be whatever file extension you use to that MIME type. And then this is what a cache manifest file looks like. It starts with the words cache manifest. There's a section of explicitly cached resources, and these things are going to stay cached until the cache is programmatically updated or the manifest file changes. So you want to make sure that these things are really static, because they're going to stay there for a while. Then there's a section of things that always bypass the cache, always go to the network. And then you have this extra bit of control where you can specify what to do if your application is offline. You can specify alternate resources. OK, so that's static data. But we're talking about tools, and that means you're authoring data, which means you need some sort of dynamic solution for storing data. That's really the heart of the problem. So what do you do with that? So in App Engine, there are 2 ways of storing data I'm going to talk about. There's Data Store and Blobstore. So Data Store is the default option with App Engine. It's it's a non-relational database, so if you come to it expecting a relational database, you might be disappointed, so you have to understand what data store is. It's really easy to use, properties on data store objects. You can see them in the data store console of App Engine. Very nice. There are a bunch of frameworks that work with it, like Objectify and JDO. So it's great, except for entities in data store can only be up to a meg, which is really not much for game data. And that's where Blobstore comes in. So Blobstore entities can be up to 2 gigs, which is really nice. And you upload them all as a single blob, but then when you want to read or write them programmatically, you have to do so in 1 meg chunks. So it's a little bit more opaque, but it's a lot more efficient. And you'll definitely need it if you're doing sort of mesh data. What you will most likely do is you will upload your data into Blobstore, and then you'll create a data store wrapper for each object that probably abstracts out or pulls out a few important properties that you want to have really available. And then you'll store the blob key of the blob, and then you'll use the two together. If your application wants to write stuff straight into Blobstore, it can do so using something called the Blobstore File Write API. This is new in App Engine 1.4.3, so it's actually a fairly new thing, but it's really easy to use and really important for game stuff. So how you use it is that you get a file service from a file service factory. You have that service create a new file with some type. You open a write channel to that file, you put your data in it, you close it. And then because most of your interactions with Blobstore will be by blob key, you ask the service to give you the key of the blob you just made and hang on to that however you're hanging on to the rest of your blob keys. So if you're uploading data to Blobstore, the process has a few steps, and it might confuse you the very first time you do it, but it's really not hard. The idea is that you're going to have a form on your client that needs to post data somewhere to get it into Blobstore. And so you need a URL, and you get that URL from the Blobstore service. So the Blobstore service has a method, create URL, which takes a handler, which is going to get called once the upload is done. So the first thing your client form does is request that URL. It makes the post. The handler gets called. And then the trick is that the first handler can only return a headers-only redirect. It can't actually respond to the client form. So it has to redirect somewhere else, and then that somewhere else can respond. So maybe sounds confusing, but it's really not much code at all. The idea is, here we are, we're asking the Blobstore service to create a URL, and we're giving it a handler to call once the upload happens. Upload happens, post gets called. The HTTP request object that came in had information about the blob keys that were just created in the upload. And you don't have to know anything about the format of that data. The Blobstore service will parse it out for you. So you can ask it to give you back a map. You can do whatever you want with that data. So in this case, I'm recommending you probably make a data store object to sort of keep track of your Blobstore object. Then you can redirect somewhere. And you can redirect anywhere you want. I usually redirect to the get method on the same servlet, just to keep everything in the same file. And then you can take any parameters you want to pass between the two and pull them out into URL parameters. So here I'm taking the ID of the asset I just made, putting it into the URL, redirecting to get. I pull out the parameters I just put there, the ID, and then I respond to the client form with that ID. And so what it looks like to the client form is upload blob, get back asset ID, which is very reasonable. OK, so that covers getting data into App Engine. That's great. But there are all sorts of transforms you might want to do on your data. Game data is sort of fraught with all these big data transforms that you need to do. So what's available for that? So there's several different options depending on the type of data you want to process. So if you've got 2D data, you want the image service. If you've got a bunch of medium-sized jobs, the task queue is a really good choice. And if you have really, really heavy processing to do, you might want App Engine backend. So I'm going to talk about each of these. They're all sort of server-side ways you can do processing. So the image service is awesome. It's just a really lightweight image processing API. It doesn't do a lot. It's not particularly featureful, but the things it does really well and efficiently. And they're probably the very first things you want. For instance, getting thumbnails out of your data, totally easy with the image service, and cropping, that kind of stuff. So here's what it looks like to use. You get an image service from an image service factory, very typical App Engine API pattern. Then the way you actually interact with the image service is you give it a blob key. The images it operates on have to be stored in Blobstore, so you give it the key to one of those images, and it will return to you a URL. And that URL is the way you're going to manipulate that image. And so important to note, the URLs can take a couple hundred milliseconds to generate, so you definitely want to do this once and then hang on to that URL. But once it's generated, it's really fast to use that URL to manipulate it. And then the way you actually do image processing is by appending strings to the very end of that URL. So this particular suffix says scale the image down to 100 by 100 and crop it. And this is really nice to be able to do all this processing via string manipulation because likely different parts of your UI and your client might want images at different resolutions or stuff like that. So it's really nice to have that control. All right, so the task queue. So the task queue is a way to do parallel background processing in App Engine. It looks to the system. Each task as it's executing looks like an HTTP request, which is really nice because that means that task queue tasks scale the same way that HTTP requests scale. And App Engine is great at handling a whole bunch of different HTTP requests. So for instance, your task can get distributed across instances and all that kind of stuff. Every task can run for 10 minutes, which may sound like a lot or a little, depending on what kind of processing you're trying to do. And by default, you can have 100 per second. Or that's the max level you can set it at. So the sort of flowchart I have on the slide here illustrates how I'm using the task queue and what I think is a really compelling use case when you're talking about game data, and that's the game data build process. So it's very common if you've got 3D data to have your artists working in some sort of 3D authoring tool, and then they export to some sort of verbose intermediate format, like OBJ or Collada or something like that. But that's not what your engine consumes, because that would be horribly inefficient. So instead, you need some sort of process that builds your intermediate data into binary data. So you need to do all these data processing operations. So that's where something like having tasks is good. So for instance, in the tool I just showed you, the idea is it syncs to my Subversion repository, gets all 90 assets at once, and then farms out a whole bunch of tasks, builds them all in parallel. So something like that, if your data build needs fit into 10 minutes, is a really nice thing. So this is what it looks like to actually set up a task queue. You have a queue.xml file that goes with all your other App Engine config files. You give it a name and a rate at which you want to allow it to process. And there are a couple other things I didn't put on the slide. For instance, you can set max number of concurrent tasks you're willing to let it execute if you want to keep an eye on your processing, your resource use. And then here's what it looks like to use. You call out a queue by one of the that you just put in the queue XML file by name. And then you add tasks to it, and each task takes a URL that it's going to hit, whether you're going to get or post to that URL, and URL parameters you want to add. And then each task executes, calls do get, and it does whatever kind of processing that method is supposed to do. So task queues are actually a really big subject, and I'm not really doing them justice. There's another talk, the hour after next, that's on nothing but task queues. So if you're interested and want to learn more, that's definitely the place to go. All right, so if 10 minutes did not sound like nearly enough processing to you, then App Engine backends might be a solution to what you're trying to do. And the idea here is that standard App Engine is really great at managing a whole bunch of requests, web requests. And that's really good for some things, but not so great for heavy processing. So for instance, every request starts at the client. Those requests have 30-second timeouts. Instances spin up and down based on load, so you don't know what's in memory or what instance you're on, or all that. So if you're doing some really heavy work, this is not a particularly good environment to be in. So for instance, in games, it's very common to have these big data processing operations that go on for like between 8 and 24 hours per build. So if you're building occlusion data or AI data or light maps or something like that, you might need like a whole lot of processing. And that's where App Engine backends come in. So the idea here is that you have an instance with no request deadline, you get more memory, and you get an individually addressable instance. So you can keep talking to the same instance, and you can sort of think about what's actually in memory. And again, backends are a really big subject. Next hour, there's a talk on nothing but backends. So I'm just sort of mentioning it here, but if you want to learn a lot more, go to that session. All right, so we've got our data stored in the cloud. We processed it into some sort of form. We know how to process it into a form that we can use. But what form should that be? So what's a good format to store your data in? We're talking about serialization. And so to me, the very first thing I thought of, and what seemed pretty obvious, is that I wanted binary data. So my meshes are all stored in Blobstore as buffers of floats. And it was actually kind of a surprise to me, because I came from the games industry first. I'm not a web programmer sort of by default. that binary data is actually pretty hard to request in the browser. XML HTTP requests did not have a binary response type until this new specification was recently added, XML HTTP request level 2, which adds 2 new response types, array buffer and blob. And so you're going to need one of those if you're going to serialize binary data. So it was obvious to me that I should use binary data, but I was talking about this with some other Googlers, and the Google body team actually serializes their data as UTF-8, which actually blew my mind that they could do that. And so Google Body, if you're interested in WebGL and you're not aware of Google Body, you should definitely check it out. Not only is it a really cool tool, but it's a really cool use of WebGL. They have about 1.4 million triangles in their mesh, and yet the whole thing is pretty snappy to use. And they get there by doing a couple of really smart things. They delta compress their geometry, so they have a bunch of really small numbers. They use variable length encoding on their UTF-8, so small numbers are encoded small. Then they configure their HTTP to be sent gzipped, which is something you can do with your headers. In the browser, some browsers can just naturally decode it. You don't have to do any extra work on the client. And then I believe the thing is, it's the interaction of gzip with the UTF-8 and all the nice small numbers. It gzips really well, and they get a fantastic compression ratio. They actually get about 3.5 times better compression than I did with binary data. That's really cool. So, and then, of course, everything's text, so you can just parse it out as a response text string, and you can get out, you can just use carcode at to sort of parse out data. This is a really cool solution. All right, so we figured out a couple options for data formats. We've got our data, but how do you actually request it from GWT? So here we're talking about Java code that's going to allow you to request this data you just worked so hard to set up. Now, GWT has a really nice class, XML HTTP request, which does a really good job of making XML HTTP requests easy and sort of abstracting away the details and all that. But the problem is that it doesn't have a few methods you need if you want to request binary data. So what I needed to do was to extend the XML HTTP request class to add 2 new methods, which are get response, the actual body of the response. What's exposed right now in the existing version of GWT is response text, which wasn't good enough because I've got a big blob of binary data. And it comes back as a JavaScript object, which is something that the Java code is not going to try to interpret. It's just going to get thrown over into JavaScript immediately. And then you needed a method to set the response type you were expecting to one of these binary types. So those are the only additions you needed to make to XML HTTP requests to be able to do this. And then what it looks like to actually use is you make one of these objects, you open a connection to a specific URL, you set the response type to one of these new binary types. You say what to do when you're done. So when it's done, you want to load data with the response body, and this load data function is a native method, which takes that JavaScript object, which I'm not trying to interpret in Java, and just passes it on over into the JavaScript side of things. And then here in the JavaScript function, I take my blob that I got passed in and make a typed array out of it. So JavaScript had not had a good way to represent binary data until the typed array specification came along. And typed arrays are a way to make, they're a way to actually get binary data. They're a way to make views on a data object. So in this case, I'm saying, view this blob of stuff as a float32 array. I could as easily say, view this as a uint8 array or whatever. There are a bunch of different types you can look at things at. And then from there on, you pass your buffer into WebGL, and off it renders. All right, so where are we now? We've stored our data, we've processed it, we've serialized it and requested it, WebGL is rendering it, everything's good. One more thing we need to know how to do, which is that we want to add interactivity to the application, so we want to make sure that it's rendering as efficiently as possible. So the way you do that is with this request animation frame API. And the idea here is that the old school way to do animation in JavaScript is with this function setInterval. And what setInterval does is that it takes a callback and a rate, and it just calls and calls and calls at that rate. And the problem with that is that your JavaScript is not necessarily in a particularly good position to know whether that makes any sense. So for instance, the client could not have the resources to fill the request you're asking it to draw. Or worse still, your WebGL could be in a background tab, so it might make no sense to update your animation at all. And yet, setInterval will just call and call and call because it's not particularly smart. So that's where request animation frame comes in. Request animation frame has a very similar format in that you specify a callback and it'll attempt to call you, but it puts the browser in charge. So the browser can take account of all the conditions that it knows about and decide intelligently whether you should be called back. So the API for request animation frame is still stabilizing. It's a very new thing. So if you want to use it, you want to use a shim layer, which, so you can see this is trying to call it with a bunch of different formats and then falling back if none of those work. And that's pretty much it. So those are the major technical sort of milestones and hurdles that I needed to overcome to make the demo. That's sort of what I learned. And to recap, all right, so if you've got static data, you want to cache it. And there are lots and lots of different ways of caching. And you should try to get to know as many of them as possible because they will help you a lot. If you are dealing with resource bundles, you're going to want the HTML5 file system API, really useful way to get a sandbox local file system. If you've got dynamic data, you're going to want data store or Blobstore to store stuff in App Engine. You're probably going to want a mix of both. Probably every game asset is going to be represented by a Blobstore part and a data store part. If you're doing any kind of processing or transforms on your assets, you're going to want a couple of different APIs. If you're doing 2D stuff, you might want the image service. If you've got a bunch of jobs that fit into 10-minute chunks, you're going to want task queues. And if you've got really, really heavy operations, you might want App Engine backends. And then for data formats and serialization, you can store your data as binary if you're using XHR Level 2. Or you can store it as UTF-8, which can be efficient, can be very efficient if you do stuff, smart stuff, like delta compressing your mesh and gzipping your HTTP. And that's pretty much it. All right, so questions, and if you want to give feedback, again, here's the speaker meter link, and there are some hashtags if you want to talk about it on Twitter. Any questions?
Do you know if there's any plans to make a wrapper around the WebGL front end for GWT?
I don't know. Yeah, I'm not sure about that. I'm sorry. Yeah.
Just out of curiosity, who are you building tools for? Who are your users? As an internal.
Me personally? Or?
Because it sounds like you work at Google, right? And I assume this is your job, like
right.
Is Google making games or recording?
Oh, I see what you're asking.
Game publishers or yeah.
Google is interested in games. So Google's really sort of has been over very recently ramping up its interest in the game community. And so what my job title is, I'm a game developer advocate, which means that I'm an ex-game programmer that talks to the game industry or people interested in games about Google technologies. So, the tools I made are actually not for any particular game. Like, we don't actually, make content. But the idea is to demonstrate, that these things can be done and get enthusiasm for them. Because this is all really new, actually. There isn't a lot written about using App Engine and WebGL or App Engine and 3D data, really. So it's really just to pioneer that stuff, but no particular use case. Anyone else? Yeah.
So I know this might go beyond the scope of the demo that you have shown, but have you put much thought into how this might play nice with a version control system? I'm assuming that these assets would all go up to Google land, right?
Yes. So yeah, that's a really good question. So I think I would not recommend that you would try to rewrite your version control system in App Engine unless writing a version control system is really your primary goal. Which it usually isn't. It's way bigger than you think it is if you've never tried to do it. I think a very reasonable workflow for a real game studio would be to check your assets into version control somewhere and then sync periodically. If you're doing something like the asset viewer tool, the idea would be on change you'd pull data in, or nightly or something like that. So I think you definitely want to work with external version control, whatever that is, and just sort of communicate between the two. Anything else? All right. Oh, yeah. So the question is it open source? And which thing are you asking about? No, not yet. The code is a total disaster because I was hacking on it right before I.O. But I intend to make this a live demo that people can use, but it isn't yet. Anything else? All right, well, thank you all for coming. Have a good I.O.